Hello, welcome to section 10.1, where we look at the language of hypothesis testing. So we go through the practice problems, and then what some of the concepts we'll see will be on the null and the alternative hypothesis, and how to determine the type of errors, so type 1 error, type 2 error, and then the kind of conclusions we can make when we are doing hypothesis testing. Okay, so we start with question 1. It says the null and alternative hypotheses are given. A. Determine whether the hypothesis tests is left-tailed, right-tailed, or two-tailed. B. What parameter is being tested? So we have from I to III, and we want to determine the type of the hypothesis we have, and then the type of test we are dealing with. So there are 3 tests that one could be doing when we are doing hypothesis tests. That will be the left tail test, the right tail test, and the two tail test. So for I, we have the null hypothesis. So we denote the null hypothesis with H0, okay, H or H0. We usually call the subscript 0 as not. So H0, that is the null hypothesis, and that is mu equals 5. And then the alternative hypothesis is mu is greater than 5. So with these 2 hypotheses, then what type of test are we looking at? What type of hypothesis test are we looking at? So our focus, or what helps us to tell the type of test we are dealing with, is the alternative hypothesis. So for the null hypothesis, there is always equality in there. So equal to. Okay. Now in some books, you will see greater or equal to, less or equal to, but there will always be an equal to component in the null hypothesis. But in this class, or the material that we use, the null hypothesis always has equal to in there. So we need to look at the alternative hypothesis to determine the type of test we are doing. Now, because the alternative hypothesis in this case contains the sign greater than, okay, then the test is right-tailed. So anytime you have greater than, then you are dealing with a right-tailed test. So that is the first answer. And then what parameter is being tested here? So you realize the parameter there is mu. Mu is the population mean. Okay, so that answers the question for I. Then we go to II, and we have the null hypothesis P equals 0.2. And then the alternative hypothesis P is less than 0.2. Okay, so the null hypothesis says the proportion equals 0.2, the population proportion equals 0.2, and then the alternative hypothesis, the population proportion is less than 0.2. Then, what type of test are we dealing with? Because in the alternative hypothesis, we have the less than sign, then the test we are dealing with is the left-tailed test. Okay, so this is a left-tailed hypothesis test because the sign in the alternative hypothesis, the inequality, is less than. And B, what parameter is being tested? That is the population proportion. Okay, P is the representation for the population proportion. Then for the next one, III, we have H0. Population standard deviation is equals 4.2, and then the alternative hypothesis which says the population standard deviation is not equal to 4.2. So what do we do? What kind of test are we looking at? Now, because the alternative hypothesis contains the inequality not equal to, then the test is a two-tailed test. Okay, so because of the inequality not equal to, this is a two-tailed test. Then for the standard deviation, for the parameter that we are dealing with, this is the population standard deviation. Sigma denotes the population standard deviation. Okay, then we go to 2. So question 2 now requires us to go through the process of writing out our hypothesis and also make certain judgments. So according to the question reads, according to the report, the standard deviation of monthly cell phone bills was $49.69. Okay, or $49.69 3 years ago. Okay. A researcher suspects that the standard deviation of monthly cell phone bills is different today. So usually when you're doing hypothesis tests, it's like there's an assumption, okay, or there is an assumption about a parameter, which usually is existing from a previous period. Then the alternative hypothesis will try to check if that result is different in present time. Okay, so in this case, the previously or 3 years ago, there was information that the standard deviation of monthly cell phone bills was 49.69. And then the researchers suspect that the standard deviation of monthly cell phone bills is different today. So A says determine the null and the alternative hypothesis. So the starting point will be, what parameter are we looking at? And that is the standard deviation. Okay, and the null hypothesis always contains equality, so equal to. So the null hypothesis will be sigma equals $49.69. Then the alternative hypothesis, we know that from looking at what are they trying to verify in present times. Okay, so the researchers suspect that the standard deviation of monthly cell phone bills is different. So then it will be that then the researcher is saying, okay, right now sigma is not equal to $49.69. Okay, so because of the word is different today, it means that today the value, the standard deviation is no more equal to 49.69. That is why the alternative hypothesis is sigma is not equal to $49.69. Okay, so now the next question, explain what it would mean to make a type 1 error. So a type 1 error is rejecting the null hypothesis when the null hypothesis is actually true. Okay, so anytime you do hypothesis test, you are likely to have 1 of 4 results. Okay, and 2 of those results or conclusions are going to be wrong conclusions. So this is one of them, which we call the type 1 error. And you make type 1 error when you reject the null hypothesis when actually the null hypothesis is true. So when we look at this very problem, then how do we explain what it would mean to make a type 1 error? Making a type 1 error implies that the sample evidence led the researcher to believe the standard deviation of monthly cell phone bills is different from $49.69, when in fact the standard deviation is $49.69. Okay, so remember the researcher is dealing with sample data now. He's testing the hypothesis with sample data. So if the researcher made a conclusion by rejecting H0, whereas H0 is actually true, then it means the sample evidence led the researcher to believe the standard deviation of monthly cell phone bills is different from 49.69, when in fact the standard deviation is 49.69. Then a type 2 error. So C is asking us explain what it would mean to make a type 2 error. So type 2 error is not rejecting H0 when H1 is true. Okay, you know, either H1 is true or H0 is true. So assuming the researcher does not reject H0, whereas H0 is actually not correct. Okay, or in other words, not rejecting H0 when H1 is true, then that will be making a type 2 error. Now remember, we don't use the word accept. So either you reject or you don't reject. Either you reject the null hypothesis or you do not reject the null hypothesis. Okay, so either you reject or you do not reject the null hypothesis. So type 2 error is not rejecting the null hypothesis when each one is true. And in the light of this question, making a type 2 error implies the sample evidence did not lead the researcher to believe that sigma is different from 4969, when in fact sigma is different from 4969. Okay, so this is just using the meaning of type 2 error to write out what it means in the light of the question. Okay. Then the next example says 5 years ago, 10.4% of high school students had tried marijuana for the first time before the age of 13. A school resource officer thinks that the proportion of high school students who have tried marijuana for the first time before the age of 13 has decreased since then. A. Determine the null and alternative hypothesis. So this is it. There was an established result, or there's an established result from 5 years, that 10.4% of high school students had tried marijuana for the first time before their age 13. But what we are trying to test now is to see, or what the school resource officer wants to test is to determine whether actually that proportion has decreased. Okay, so there is a word in there that we should pay attention to. So whether the proportion has decreased. So remember, the null hypothesis always contains equality, but the main thing, the starting point will be what parameter are we working with? Okay, so generally the parameters that we can work with are the standard deviation, that is the population standard deviation, the population mean, the population proportion. Okay, there are many more that are possible, but then in the light of this class, we are just focusing on these three. These are the things that you could see more often. Okay, so because we are talking about a percentage of high school students, okay, that talks about proportion. Okay, so a proportion of high school students. So P will be the parameter, which is population proportion. So P equals 0.104. That is for the null hypothesis. Then the alternative hypothesis will be P is less than 0.104. Now, how were we able to determine that? By looking at what the school resource officer was trying to check. The person was trying to check if the proportion has decreased since then. So it means less than. Okay, so it means the alternative hypothesis, you assume that the proportion has decreased, or the proportion is less than 0.104. Okay. Then we go on to B. B says, suppose in fact the proportion of high school students, B, suppose sample data indicate that the null hypothesis should be rejected. Okay, so this is where they have done a test and then they are giving us the indication that the null hypothesis should be rejected. State the conclusion of the researcher. So if we are rejecting the null hypothesis, then how do we state our conclusion? That is what we look at with this question. So it reads, there is sufficient evidence. Okay, so these are keywords that we always look at. So there is sufficient evidence to conclude that the proportion of high school students who had tried marijuana for the first time before the age 13 has decreased. Okay, so there is sufficient evidence to conclude that the proportion of high school students who had tried marijuana for the first time before the age 13 has decreased. Then we look at C. C reads, suppose in fact the proportion of high school students who have tried marijuana before the age 13 was 10.4%. Okay, so suppose in fact the proportion, so the reality, what is actually true, is that the proportion of high school students who had tried marijuana before the age 13 was 10.4%. And what hypothesis is that? That is the null hypothesis. So suppose that the null hypothesis is the true result in reality, but then the sample evidence led the researcher to settle for H1, okay, that the proportion has decreased. Then what type of error are we looking at? So that will be a type 1 error. Type 1 error is rejecting a true null hypothesis. Okay, so rejecting the null hypothesis when the null hypothesis is true. So C, the SRO, that is the school resource officer, committed a type 1 error because he rejected a null hypothesis when in fact it is true. So this ends it for section 10.1. Thank you.